All right, guys, we are not going to do a Nearpod today simply because I didn't make anything interactive with these because I knew it was going to have to be pretty straightforward. And also, you don't have a DMR because this goes along with lesson 9, which we started yesterday. So there's no other DMR because this is still the same lesson. So we're going to start proofs today. We did algebraic proofs yesterday. Now we're going to incorporate it with geometry. So first we're going to do kind of these mini, just here's a diagram. What statement can you make from the diagram and what is the reason for that statement? And these would kind of be pieces of proofs. So I'm on page 22 of your packet. Okay, and it says write a geometric statement that best fits the figure. Then write the postulate. Postulate is just, oops, I need my pen thing. Pause. And we're back. Okay, so postulate is just a fancy word for a theorem or a definition, so don't let it scare you. This pen is way too large. I want it skinnier. Okay, so sorry, I'm trying to get everything organized on my screen. So it says, write the postulate or definition used for the reasoning of your statement. Segment addition, angle addition, vertical angles, supplementary angles, complementary angles, angle bisector, or midpoint. So most of these we learned either in lesson 6 or when we went over those terms on the first day besides segment and angle addition. So we're going to talk about those as we get to them. So number 1 is kind of a weird one because you look at this and you're like, all right, they're not vertical angles. They're not supplementary angles. It's not bisected. So what can I say about this picture besides the fact that it's two adjacent angles chilling, making a bigger angle? Okay. What they need to say, I don't want highlighter, I want pen. Okay, so what they want us to say is that the measure, I don't want yellow either. I'm sorry, I'm going to get it together. The measure of angle SGT, that would be this, SGT, plus the measure of angle TGH, that would be this, TGH, should equal the measure of angle SGH, which is the Big Papa angle. So all this is saying is, okay, let's say SGT is 25 degrees. And let's say TGH is 10 degrees. Then the measure of angle SGH would be 35 degrees. They're next door. The two together make up the bigger one, so we would add them up. This is called angle addition because we're adding angles. Postulate. And like I said, don't let the P word scare you. If you put angle addition, I would take it, but you're never really going to have to do this from scratch. It's always going to be a drop down or a multiple choice or something. So don't focus on this word, focus on angle addition. All right, number 2, we should know what kind of angles 7 and 8 are. So think about what kind of angles 7 and 8 are and look at what it lists in the directions. If you said vertical angles, you're right. Okay. So these are vertical angles. So we can either say the measure of angle 7 is equal to the measure of angle 8, or we could say angle 7 is congruent to angle 8. Either one means the same thing. If you want to write the other one, the measures are equal. Congruent angles and equal measure, same thing. Why? Vertical angles. And now sometimes in a proof, depending if it comes from your module, if it comes from the people who write LEAP, if it comes from another textbook I stole it from, it might say vertical angle theorem. Or in front, it might say definition of vertical angles. We don't care. There's no difference for those as far as we're concerned. All we care about is that these are vertical angles. And because they're vertical angles, we know they're congruent. So that's how we can make this statement. All right, I'm going to erase so I can skedaddle down. think I can scroll on this tablet. I just haven't figured out how to do it yet. One day I'm going to impress y'all and know. Okay, number 3. This says AB. Well, this is segment ABC, or segment AC with a B in the middle. And it says B is the midpoint of segment AC. That means AB should be congruent to BC because B is smack dab in the middle of them. So we're going to say AB with the little segment hat is congruent to BC with the segment hat. How did we know those were congruent? Because we knew what this word meant. So our reason for this is definition of midpoint. Definition of midpoint. We know the word midpoint means a point that bisects a segment in 2 equal pieces. So that's how we could say these were congruent. All right, the next one. It's kind of hard to see, but 1 and 2, I just wrote over it. But 1 and 2 are forming a right angle. They put that box in the corner. So we're going to say the measure of angle 1 plus the measure of angle 2 should equal 90 degrees. And this is going to be the definition of, and I'm just going to write def, short for definition, of complementary angles. And if you remember from one of the first lessons we did in this unit, right, we learned that complementary angles add to 90. Once again, the definition of part might not be there. It might just say complementary angles. It might say definition of complementary angles. Regardless, don't let it screw you up. You know these angles add up to 90. You know those are called complementary angles. Because these are complementary angles, that's what means we can write this statement. All right, number 5. This diagram is telling us QY bisects angle XQZ. So this is something we actually constructed those first few days of school. This is telling us that this angle and this angle are congruent to each other because this guy comes in and slices the angle in half. So we're going to say angle XQY, which is the one further to the top, is congruent to angle YQZ. And if we wanted to talk about the angle's measures, we would just put the little m in front and say the measure of angle XQY is equal to the measure of angle YQZ. So if we're talking about the numerical measures, we put the m's in front and change the congruency sign and equal sign. Okay? Regardless, I'm most concerned that we know they're equal to each other and not supplementary. And this is because we knew what this word meant. And what is being bisected? An angle. So this is definition of angle bisector. Definition of angle bisector. Okay, if we look at number 6, it's kind of like number 1. Nothing's happening. They don't give us any phrase underneath. This is just a segment with a K thrown in the middle. Yeah, K looks like he would be the midpoint, but it doesn't tell me that, and it's not marked, so I can't assume it. So this is going to be very similar to number 1. We're going to say JK plus KL, so the measurement of JK plus the measurement of KL would equal the measurement of JL. So let's say JK was 3, and let's say KL was 2. I know they look congruent, but I'm just doing this for, an example. Then the whole length of JL would be 5. Because this little chunk plus this little chunk meets together, it makes 5. And our reason is called segment addition postulate. So just like we added angles, now we're adding segments. And once again, don't let the postulate word scare you. All right, if we look at this one, there was a diagram like this on one of the homeworks. I think it looked like this, and it had like a 46 right here and an X. And like a lot of people email me, which I'm glad you were asking your questions, and they're like, I don't know, there wasn't an example like this. This is what we call a distractor. They're purposely sticking this line right here and right here to throw you off. These two angles have nothing to do with this over here. I know sometimes you're like, yeah, but I don't know, I need to consider everything. I'm totally with you. But what we're focusing on is these two, and they fall on a straight line. So we know they're going to add up to that magical 180. So we are going to say the measure of angle 4 plus the measure of angle 3 equals 180. Or you could say 3 plus 4. It doesn't matter. Now, I can either say this is definition of supplementary angles, kind of like the complementary one up there. These are supplementary angles. Or I can say linear pair, because if you remember, a linear pair is when I have two supplementary angles that are also adjacent. They fall in a straight line, which these do. And a lot of times after linear pair, they'll have theorem. Once again, don't focus on definition, postulate, theorem. Focus on the geometric part, the linear pair. Why can I say these equal 180? Because they're a linear pair. Okay, I'm going to do one of these next ones, and then you're going to try, I don't know how many there are. Hold on. All right, I'm going to do, wait, are there 4? There's 6. Okay. Sorry, this is a little too zoomed in for my eyeballs. Okay, there we go. So I'll do 1 and 2, and then you can do 3, 4, 5, and 6. So these are more what we learned about in lesson 7 with the different angles. I want a new color. Let's go with you. Okay, so part B says write a geometric statement for each pair of angles using corresponding alternate interior, alternate exterior, same side interior, vertical, or linear pair. So those are my 6 options. So I'm looking at this picture, asking myself, okay, does that mean the angles are congruent or the angles add up to 180? Writing whatever statement that is, and then writing what my reason is. My reason is going to be one of these angle types. Okay, so if I look at number 1, whoa, that's way too big. My bad. Apparently, when I change colors, it also makes it fat. These two add up to 180. Okay, so I'm going to say the measure of angle 2 plus the measure of angle 3 should equal 180. Why? Because they are a linear pair. And like I said, a lot of times after linear pair, they have that word postulate. I'm just trying to give you that so when you see it on a test or on LEAP, you're not like, what is this, Greek language? I don't know. But if you just put linear pair, that's fine. Okay, if we look at number 2, these are congruent angles. They're both obtuse, okay? So I'm going to say angle 6 is congruent to angle 7. Or if I wanted to, I could say measure of angle 6 equals measure of angle 7. Same thing, all right? What kind of angles are they? Alternate exterior. They're on the opposite sides of my transversal and outside the parallel lines. So I want you to do the same thing for 3, 4, 5, and 6. So pause the video, try 3, 4, 5, and 6 on your own, and then we're going to go over them together. All right, hopefully you didn't find this too bad. So these, all right, even though they're in a parallel line situation, kind of just like number 1, nothing is happening with this line down here. Everything is happening with that top line. So we're just going to say angle 1 is congruent to angle 2. And don't let the parallel lines throw you off. These are just vertical angles. So vertical angle. And like I said, a lot of times it says theorem after. Okay, for number 4, these guys are not congruent. Instead, they are supplementary. So we're going to say the measure of angle 8 plus the measure of angle 9 should equal 180. And these are same side. They're on the same side of the transversal. Interior, they're inside those parallel lines. And a lot of times when it's the angle type, I should have written it up here, they put theorem after. And the technical theorem for same side interior angles or for alternate exterior angles, for alternate interior, exterior, and corresponding, the theorem is if two parallel lines are cut by a transversal, then alternate exterior angles will be congruent, or alternate interior angles, or corresponding angles. The theorem for same side interior angles is if two parallel lines are cut by a transversal, then same side interior angles will be supplementary. Sorry, lost my train of thought. So sometimes on LEAP, instead of saying alternate interior theorem, they will write all that out, and that will be the choice. And you are going to look at all those words and be like, I don't want to read all this mumbo jumbo. Look for the key words of alternate interior angles, or the angle type. Okay. All right, and then 5 and 6. Number 5, these are the ones people seem to struggle with the most. These are corresponding. Forgot my squiggle. Okay, their positions match. They're both underneath the parallel line and to the left of the transversal. Okay, and then why? Corresponding angles theorem. That's my angle symbol with an S because I'm too lazy to write the word angles. All right, and then the last one, these are the ones we're probably most familiar with, alternate interior. So we got angle 3 is congruent to angle 4. And it is because of alternate interior angle theorem. All right, we're going to start the proofs. You take a deep breath. It's going to be okay. We're going to get through it together. All right. Let's see what a festive color is for this. Oh, purple. We'll do purple. It's not very festive, but it's my favorite color. Okay, so like I said, you are not going to have one of these that is strictly writing it from scratch. So if you look at your module, you look at these in your module. We're not doing them in the module because they just give you the diagram and a given and say prove this and a blank square. And it's daunting. Okay? So you will always, on your test and on LEAP, have like a drop-down menu or a drag and drop or multiple choice or something to help get you there. So you at least have some kind of process of elimination. All right, your next test will have 2 to 3 questions out of the like 20-ish questions that will be on proofs. So I don't want you to get frustrated and think this is the whole test, I'm going to fail. The majority of the test is building up to this. No, sorry, the whole unit has been building up to this. And the majority of the test is algebra questions, like what was on your quiz and stuff like that. So don't get frustrated. Don't shut down. If you have any questions, you can ask me tomorrow or email me. Okay, so this is in lesson 9 of your module, but like I said, we're just going to do them in this packet. This is on page 24 of your packet. Okay, so it wants us to justify these things. So it says the measure of angle X plus the, no, I can't even read, y'all. Okay, the measure of angle W plus the measure of angle X equals 180. Now, I'm going to be honest with you. These ones we're doing today are kind of weird because they're not hard. They're just weird because they don't start with a given. Usually, the ones we do tomorrow will start with a given. So you kind of have a starting point. These just go boom, full in. So y is W plus X equal to 180. Imagine if this would have been on the page before. We would have said W and X is equal to 180 because it is a linear pair. And you can write linear pair theorem after it if you want to be fancy like this and write linear pairs form supplementary angles. You can, but like I said, we're going to focus on those key words because you're going to be picking from choices. Okay, so we have W and X equal 180. And then over here, all right, on the statement side, we don't have anything here, but we know the reason is linear pairs form supplementary angles. There should be angles. But if I look at this, well, this is a linear pair, this is a linear pair, this is a linear pair. So how the heck do I know which one to put? So we're going to sneak a peek at the next line, which says W plus X. Where does that come from? That comes from right here. Is equal to Y plus X. And then this is some property of equality. So what we need to put on our next line, the linear pair we need to put there, is this one. Okay, so the measure of angle Y plus the measure of angle X should equal 180. I didn't randomly choose. I looked at the next line and saw what it talked about. And that's another linear pair that forms a supplementary angle. Y'all, my crazy neighbor, he pulled out a trumpet earlier and he was playing taps and when the Saints go marching in. So brace yourself if we get a soundtrack. Okay. So now what they did, I want a different color, is took this and took this and set them equal to each other. Because, hey, if they both equal 180, I can get rid of the 180 and say, oh, hey, well, then they both equal each other. If you remember from when we learned the properties, this is called the transitive property. It's basically when I substitute in a whole equation. Now, from this line to this line, look at what changed. W plus X. No, he disappeared. Equals Y plus X. No, he disappeared. So if these are both being added and they both went away, what could I have done to get rid of them? How do I get rid of something that's being added? I subtract. So this is kind of like those algebraic proofs. So this goes away, this goes away. So what did we do to both sides? Subtract. So subtraction, property of equality. Then this says the last step is always what you want for your end result. So normally it'll say this is what you need to prove, and that'll be this line. And then these three dots mean therefore, the end of the proof. This is stating that you've reached your conclusion. I'll be honest, I didn't use this till college, so don't worry about the three dots. All right, you did your first proof. Woo! Celebrate. Go get yourself a cookie. Okay, we're going to skedaddle on to the next one and eat a cookie from me as our diet for this wedding. Can I fit both of these? Okay, there we go. All right, we look at number 2. Given the diagram to the right, prove that the measure of angle W plus the measure of angle X plus the measure of angle Z equals 180. Okay, so now that this says prove this, if you want to kind of cheat, you know this is where you got to end up. This has got to be your last line. So this has to be my last statement. So I'm going to say the measure of angle W plus the measure of angle X plus the measure of angle Z, I ran out of room, equals 180. I know that's where I have to end up. So if we look at the first one, it says the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180. The reason, the sum of angle measures in a triangle is 180. Now, sometimes this may say triangle, angle, sum. Or it might say triangle interior, because it's all the triangle angles inside. Angle sum, they might put theorem at the end. You need to focus on the words sum and angles in a triangle. Okay? W, the measure of W, is equal to the measure of Y. What kind of angles are those? Vertical. The vertical angles are equal in measure. Then they take these two lines and they do some magic, all right? X is still here. Y is not here. But there is a W. and Z. Okay? So what happened here? That I want a different color. I like how I announced to y'all I need a different color. Like y'all can fix that. Okay, the Y changed into a W. Why did it change? Because right here in between, we said, oh, hey, W is equal to Y. You can replace them with each other. When we replace something with each other, that's called substitution property. You know, like a sub, like who's here when I'm not here. You wish I wasn't here because I'm annoying. All right, so you replace W with Y. No, Y with, W with Y. I was right. All right, looking at the next one, who is apparently also number 2. We're changing him to number 3. Given the diagram to the right, prove that the measure of angle W is equal to the measure of angle Y plus the measure of angle Z. What am I going to do? Ooh, that circle was wonky. I'm going to, there we go. Oh, I didn't mean to do that. Whoops. Hope you were done writing that. Oh, I can undo. Wow. Okay. Sorry, y'all. It's the little things. If I know this is what I need to prove, I'm putting that down there. So measure of angle W is equal to measure of angle Y plus measure of angle Z. That's where I need to end up. That's my end goal. So this says W is equal to X plus Z. We're ignoring this little thing at the top. W is equal to X plus Z. Why is W equal to X plus Z? Because the exterior angle of a triangle equals the sum of the remote interior angles. This may also be called triangle exterior angle sum. It means the exterior angle is equal to the sum of the two remote interior angles. And remember, the remote interior angles are the ones that are not next inside the triangle, but not next door to the outside angle. Okay, then it tells us X is equal to Y. So here's X, here's Y. Why are they equal? Because they're vertical angles. Then, all right, we got to look at this line compared to this line. W equals X, Y, Z, Z. What's different? X became Y. How did that magic happen? Because of this. X is equal to Y. We substituted in. We replaced one with the other. And if you're wondering why these were substitution and that one at the top was transitive, it's because the one at the top, we took a whole equation and set it equal to another whole equation. These were just taking one angle and replacing it with another angle. All right, let's see what we got left here. Oh, just 2. All right, cool. We can get through these 2, friends. How about you try this one, number 3? Don't try number 4. He's a little scary. Try number 3, all right, by yourself. So pause the video. Well, after I finish explaining, pause the video. So these are all the things you're going to need. These are all your reasons. They're all the words. These are all your statements. Figure out which one goes where, all right? And if you just want to draw lines, if you're going to be checking your own work. So if you can figure that out, have at it. So pause the video, and then we'll go for it. Okay, here we go. So number 3 says, in the diagram to the right, prove that the measure of angle Y plus the measure of angle Z equals the measure of angle W plus the measure of angle X. You need to write a label in the diagram that is not labeled yet for this proof. So we labeled this A. That's who we had labeled. I need a pen. Okay, so first, it told us the measure of angle A plus the measure of angle Y plus the measure of angle Z is equal to 180. Okay, A, Y, Z equals to 180. Is that because the sum of angle measures in a triangle is 180? That's these 2 options. Is that because of subtraction? Or is that because of substitution? Hopefully you knew it was because of oh, y'all, come on. One day technology will not hate me. But that day is not today. Okay. Sum of angle measures in triangle is 180. All right. So now we know that this is what we're trying to prove. So I'm going to go ahead and get rid of that one right now and put it at the bottom. Measure of angle y plus measure of angle z should equal measure of angle w plus measure of angle x. Why is that one going on at the bottom? Because that's what they want me to prove. So I'm getting rid of him. And then over here we got rid of one of these. All right, so we knew a plus y plus z equals 180. So our next option for a statement is either all this mumbo jumbo where we say a plus y plus z equals a plus w plus x, or we say a plus x plus w equals 180. Well, we can't really say these two equations are equal to each other when we don't even know what all this equals yet. So this one has to go next. Measure of angle A plus measure of angle X plus measure of angle W equals 180. And this is also going to be sum of angle measures in triangle is 180. All right, so that's that. All right, so now, and we did this. So now we have this whole mumbo jumbo. I'm not writing it because I know it's not going to fit because I write like a giant, okay? But what they did was a plus y plus z, that's the first part, is equal to a plus x plus w. That's this part. I know they flip-flop, but we're not concerned about that, okay? How do we know those equal each other? Well, what we did was we said if all this equals 180 and all this equals 180, then we can get rid of the 180s and say these equal each other. The book says this is substitution. Miss Terrebonne says this is transitive because transitive is really when you substitute a whole equation. Y'all hear my dog crying? She's throwing a fit. I'm sorry. I would take either one on the test, but like I said, you ain't going to have to pick because it's going to be an option. So is it subtraction or substitution? Substitution is more correct. And then if you look, all right, this line to this line, so this one really goes right here. The A is nowhere to be found. The Y is still there. The Z is still there. The A is nowhere to be found. The W is still there. The X is still there. How did we get rid of these A's? We subtracted. So this is subtraction. And I'm going to write POE, property of equality. That means it happened on both sides. So what this says is this triangle adds up to 180. This big triangle adds up to 180. So that means these three angles are equal to these three angles. Well, hey, if I get rid of this in both of them, that means these two angles are equal to these two angles. All right, we do have one proof left. It is just going to be for my honors friends. So if you are in my second hour, you can just hang tight for a second because I'm going to explain the homework in a minute. It's kind of an easy one. All right, so if we look here, honors friends, this says in the figure to the right, AB is parallel to CD. All right, so I'm going to make those longer. Ooh, that was ugly. So this is one set of parallel lines. And then BC is parallel to DE. That's another set of parallel lines. It wants me to prove that angle ABC, who's right here, is congruent or measures equal to CDE, which is right here. Okay, so first it says AB is parallel. These are my parallel symbols. I know they're normally slash, but these do them straight up and down. And BC, all right, AB is parallel to CD and BC is parallel to DE. My bad. Okay, that is given to us. And the proofs we do tomorrow are all going to start with these givens. Then it says the measure of ABC is equal to the measure of DCB. So what you need to do is ignore all this for a second. Put your hand over it, do something. I'm putting my hand over it, but you can't see my hand in the video, and I don't want to color it out. Right? All we're looking at is these blue parallel lines, and this being our transversal. These are alternate interior, inside the lines, opposite side the transversal. So that goes there. If parallel lines are cut by a transversal, then alternate interior angles are equal in measure. That's what I was telling you, that would be the alternate interior angle theorem. Then, let me take another color. It says DCB, who's right here, is equal to CDE, who's right here. So now we are looking at these parallel lines and this transversal. Very ugly picture, right? But they're inside and on opposite sides of my transversal. So this is another set of alternate interior angles. So now what they do here, and we should have known this would have been our last statement if we would have needed to be putting the statements in order, because that's what we're trying to prove. They say if ABC is equal to DCB and DCB is equal to CDE, we can get rid of both of these and we can say, oh, hey, these guys are equal to each other. If they're both equal to the same thing, they're equal to each other. Think about this as like hello is the same as hola. No, let me do it reverse. All right, hola is the same as hello. Hello is the same as bonjour. We can get rid of both of the hellos and we can say bonjour and hola are the same thing. All right, little cross-curricular action happening there. All right, so that means this was substitution. We substituted one value for the other. All right, what everyone's homework is going to be, and it's actually going to be due tonight at midnight, simply because I don't think this is anything you're going to need my help for. I'm trying to give you a gimme homework. You are going to do this lovely little crossword puzzle, all right? So in case you don't know how to do a crossword puzzle, let me help you out. Number 1 says A and C are complementary. Angle A, and angle C are complementary. Angle B and angle C are complementary. So they want to know, what is the reason for that? The reason for that is that it was given. These are my crosswords. So what I'm going to do is find number 1 across right here and write the word given. Okay, then let's do another one. Let's say, oh, my stuff is all moving. It's making me kind of nervous. Okay, let's look at number 4. This one's pretty self-explanatory. Angle 1 and angle 3, okay, they're congruent because vertical blank are congruent. Vertical what? Vertical angles. That's number 4, and these are down. Let me erase. So this is angles. And then this was given. So what you're going to have to do for this, instead of trying to do the Google form that does not like me when I try to submit pictures, I'm going to post an assignment on Google Classroom. It's not going to be a form. It's just going to be an assignment, okay? And you're going to have to take a picture of this and just submit the picture with the assignment. If you do the picture on your phone and you try to submit through the Google Classroom app, okay, you're going to go to the assignment, you're going to do add or something, I don't know. There's an arrow at the bottom. You got to click that arrow and then it'll give you the attachment option. If you don't click the arrow, you're just going to be staring at the screen like, what do I do? You have to click the arrow and then it'll say attach, and then you could attach a picture. All right, so this is going to be due tonight at midnight. If you were super confused about proofs, don't fret. We're doing them again tomorrow. I hope you have a fabulous day.